So today we're looking at functions, and these functions are going to be written in what we call standard form today. These are line functions in standard form. And what I mean by standard form is very simple, that here's an equal sign and x and y are on the same side That's it. X and y are on the same side. Okay. So if x and y are on the same side, that means we are in standard form. We have other forms here. We have something called slope-intercept form. And this is y equals to mx plus b. And maybe if you had a adventurous 8th grade teacher, he might have taught that to you, or she might have taught that to you. So there is one great thing about standard form. We'll talk about that right now. But let's talk about what this even means. So if I tell you x and y balance out to become 10, really it's a give and take relationship, right? Think of your parents. It's give and take all the time, right? If one person wants one thing, the other person might have to sacrifice a little bit. If someone else wants one thing, you gotta sacrifice. Maybe you guys sacrifice for your parents so they can have something, or they sacrifice for you. Because in the end, we only have $10, let's say. Or our goal is $10. So let's use this example of your mom and dad, and they're trying to pay for parking. Parking is $10. Simple example. And I'm going to create an x and y table here so we can see the results of our little bargaining, a little negotiation here. So if we'll call this mom is x, and y is dad, okay? Just so that we have in our head this idea. This could represent anything. But let's say if mom has no money. If mom has no money, then to make this equal to 10, dad has to carry all the weight. He has to have $10, right? And 0 plus 10 is 10. That works out. What if we go the other way? What if mom has $10? That means dad doesn't have to bring out anything. And some of our families, maybe your mom carries all the money and your dad just has an empty wallet. He charges everything. Okay? What if your mom says, I only have $2? Then your dad has to bring out $8. What if your mom says she has $8? Then your dad brings out $2. And the idea is these are reactionary. We give us one value and we have to react with the other value just to catch up. And what happens is these end up to be points on our graph. We can call these an ordered pair. And we can say this is 0, 10. This is 10, 0. This is 2, 8. And this is 8, 2. Right? So we can do this over and over. We can do this 1,000 times. But let's go ahead and take a look at what this graph looks like. If my x values are my horizontal and my y values are my vertical, if I count it, I'm just going to count by twos. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay? 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. We can plot these points and we can see that there is a actual tangible relationship. We can see that this is going to form, let's see, when x is 0, we walk up, y is 10. If x is 0, y is 10. Y is 10. If x is 10, 10's way over here. X is 10. We said our y value is 0. Right? So I want you guys to look at this as x is going left and right, and y is going up and down. So x is, you guys ever play, you guys ever go to the arcade where there's this ball dropper where it drops balls down, and then you have to go left and right to catch it? That's your x idea. Okay? So we move left and right for our x, and your y value is almost like, what height are you at? At 0, my height was 10, but at 10, my height was 0. Now, I've drawn just 2 points right here, and I want to say, now this is enough for us to complete a line. You only need 2 points to draw a line. Now, the cool thing about this line is that this line represents all the possible answers to our x plus y equals to 10. Why did I say that? Well, we plugged in 4 possible answers, and let's go ahead and see if these points are on the graph. Is 2, 8 also on this graph that we drew already. 2, 8. Oh, it is there. How about 8, 2? Is 8, 2 there? 8, 2? Yeah, 8, 2 is there. Well, let's pick a point on this graph and see if that's an answer to our equation. If I go up 4, does that look like 6 to you? Okay, if x is 4, is y going to be 6? Let's try this. If x is 4 and y is 6, does that still give us 10? It does. It does give us 10. If I pick another point, if that's u6, if x is 6, y looks like it's going to be 4. If x is 6, y is 4. Yes, this is 10 also. And what I want to bring up is this main point actually, and this is a weird point. It's that these points here represent x plus 10, x plus y is equal to 10. But a line is actually all the points in between it. So if I go ahead and let's draw this in green now. A line is actually all the dots, all the points that x plus y equals to 10. And if I keep drawing dots here, if I keep drawing dots over and over and over and over again, we end up with our line. Okay. So do you guys want to figure out all the decimal points in between? Do you guys want to figure out the 0.1, 0.2, 0.3, 0.4, 0.5? No. And that's why we just draw a simple line, and the line represents all these possible values. And the big deal about learning how to read lines and create lines, it makes everyone's life easier when it comes to reading the situation. Imagine if you told someone x plus y equals to 10. What the hell does that mean, right? But if I showed you a graph instead and say, hey, look, 2 becomes 8, 4 becomes 6, 6 becomes 4. Hey, there's a trend, and we can map out that trend. And everyone can see there's a what we call a negative correlation here. Values are decreasing, right? So the more money your dad has, than your mom has, the less money your dad has to plug in, right? So if your mom has 10 bucks, your dad doesn't have to take out any money. If your mom has 8 bucks, your dad has to bring out $2. So there's this relationship here. You could have said, you know what? This is you, and this is your, let's say, your brother. And you guys are trying to buy a gift for your parents, buy something, maybe go someplace. The more money you give, the less money he gives. And we can see this relationship from this simple graph. Now, our first way to talk about how to graph these in standard form is actually one of our easiest ways of graphing, and we just did that. We did it with our first 2 points. Now let's go and give you guys a different problem here, and we'll talk about that. So graphing in standard form. And maybe I might just abbreviate this as STD, okay? STD form for standard, okay? It's not the other STD you guys are thinking about. So if I write 2x plus 3y is equal to 6, okay? Now this problem is, you know what, slightly a little bit more difficult because I threw other values in there. But I want us to think of an easy value we just used in our previous example that would help me find 2 easy points, okay? And let me write my x and y chart here. And here's what we do. We plug in 0. If x is 0, what does y have to be to catch up? Because why do we do this? What's 2 times 0? 2 times 0 is nothing, right? So I'm not going to write that. So we're left with 3y equals to 6, and this problem takes us back to literally like our second lesson in algebra. How do I solve a one-step equation? Y has to be 2. Now, is this true? If x was 0, would y be 2? If x is 0 and y was 2, isn't 3 times 2 6? You carried all the burden. And the reason why we want to plug in 0, it makes life easier when it comes to coming up with 2 simple points. Well, fine, we made x 0. Let's try making y 0 now. Just write this. This is 0, 2. That's one point that we can graph. Now we're going to make y 0. 2x plus 3 times 0 equals to 6. Well, 3 times 0 is 0, right? So we're left with 2x equals to 6. We don't have to write this anymore. That's gone. We use our one step to solve for this. X equals to 3. Okay, so if y is 0, x must be 3. 3, comma 0. Let's go ahead and graph this graph now. If x is 0, y is 2. If x is 3, y is 0. If I draw my line, we have our line already. So there's a couple of takeaways I want you guys to be able to catch. First, to draw any line, you need 2 points. If I don't have my second point, where are you going to go? Like honestly, where would you go? Like, would it be up here? Where would it go? Like, if I don't have a second point, we don't know where to go. I want you guys to think about, in football, can you play football with one person? No. Don't you have to throw the ball to someone? Baseball, basketball. I mean, well, basketball, who do you throw the ball to? You throw it to the hoop, right? That's your destination. So you need 2 points to draw a line. And that's what we're looking at, 2 points to draw a line. We can find 2 points easily by plugging in an x or a y. Now, we actually have some special terms for these special 0 points. Special 0 points. Now, when we hit the y-axis, so we call this y and call this x, we call this my y-intercept. And the y-intercept, in English, right, the word intercept just means to run into, to meet. We use this word popularly in sports. So-and-so intercepted the ball, right, in football, because he went and he ran into the ball before the other person got into it, right? In the police, the highway patrol has a car called the Interceptor, right? And this Interceptor is supposed to drive faster so it can catch up to people who are speeding. It intercepts them. In spying, if you intercept someone's email, if you intercept someone's message, right? In World War II, they would tap the lines of the Germans so they could intercept their messages to figure out what they were saying. So this word intercept just means to meet up, to hit. And guess what? We're hitting the y. That's why we call this the y-intercept. What do you think the other one's called? It's called the x-intercept. So math people are all about labeling something as simple as possible. Just call it what it is, right? That's the y-intercept, that's the x-intercept, that's just call it what it is, make life easier. So how do we come up with our x-intercept and y-intercept? I want you guys to notice this. I'm going to write this point here. This is 0, 2, and this is 3, 0. And you want to notice something kind of interesting. If I ask you for the y-intercept, I want the y value when x is 0. Okay, I want the y value. So I want you to block out the other variable. If I say y-intercept, look for y and you block out x. Okay, let me say this again. How do I know? Because the prompt's going to say, tell me the y-intercept. And kids often forget which one is 0. Which one do I plug in 0 to? Is it the x or the y? Hey, if I ask you for the y answer, you block out the other guy. You block out x. So x is going to be 0. If I ask you to find the x-intercept, okay, tell me the x. I want to hear x. You block out the y. You make y 0. So we're going to solve a similar question to this. And we're going to say 3x, oops, let's do another example with these types of questioning. So find the x-intercept and, whoops, and y-intercept. And that is abbreviated y-int and x-int. Okay? And here's our problem. Our problem is going to be 3x plus 6y is equal to 18. 18. Let's do that. 18. So to find the x-intercept and find the y-intercept, I want to ask you guys, what do we block off? To find the x-intercept, remember, I want the x, so we block off the y. Automatically, we're going to say y is 0. So 3x plus 6, 0 is equal to 18. And that's the work I want you guys to show. 3x plus y, because if I'm solving for the x-intercept, I'm going to block the y. Well, this is pretty easy then. 3x equals to 18 divided by 3. X is equal to 6. So my point is 6, 0. That's my x-intercept. Again, what's my x value? We block off the other one with a 0. What's my y-intercept? So let's do it over here. 3 blank. So if I'm looking for my y-intercept, we block off our x value. So it's going to be a 0 plus 6y is equal to 18. 6y is equal to 18 because 3 times 0 is a 0. Don't write it. So divide both by 6. Y is equal to 3. Y is equal to 3. So let's go ahead and graph these. So there's two ways of graphing it. One, you can look at the points. We said 6, 0, and we said 0, 3. We can do that. Or just say this. My x-intercept, x is equal to 6, and my y-intercept, y is equal to 3. So my x-intercept is 6, and my y-intercept is 3. So when x is 1, 2, 3, 4, 5, 6, yep, this is 6, 0, and my y-intercept is 1, 2, 3, we have 2 points, and now we can represent this function with a line. Okay, now I'm going to do something here. I'm going to see if any of these points that I just drew on the line actually work for the function. Okay, we said a line is made up of a million, trillion, cajillion, infinitely many points. So I'm going to pick an easy one. Let's go this way. That's a point. So let's see, this is 2 and 2. Is 2 and 2 going to work? 2 and 2. We're going to check if that point is an answer, is a solution for this guy here. Let's try another one. If I pick a point over here, that looks like 4, 1, 4, is 4, 1, a solution for this problem here. So we picked easy points here just to verify it. So my point is that this line represents all the possible answers, okay, all the possible answers. So if I just match these lines up, I have a point. Now the x value is 2 and 2, right? 2 and 2. Let's try it. 3x plus 6 y is equal to 18, and we said 2 and 2. Is 2 and 2 a possible solution here? 6 plus 12. Hey, is 6 plus 12 18? You can use a calculator if you need to for this. 6 plus 12 is 18. Yeah, that totally works. Oh my gosh, our graph totally works. Well, let's try one more time. 4, 1. We said 4, 1 looked like a point that works. So 3, 4 plus 6, parentheses 1, 12 plus 6, is this also 18? Oh my gosh, it also worked. Now I could have picked decimal values here. I could have done that. They're harder to look, they're harder to see, but we could have done that, and all those decimal values also would have worked. So one of the first skills that you guys are going to be working on IXL is really just answering the question, hey, what are the intercepts? Okay, what are the x-intercepts? What are the y-intercepts? By plugging in the 0. The next thing you guys are going to do is you guys are going to graph this equation. What we did here, just graphing it by plugging in the zeros for standard form. So let's go ahead and take a look at that. Okay, here is S.19, one of your first assignments today for the second assignment for IXL. And look, they give you this crazy 10x plus 9y goes to 90. All right, so let's go ahead and make this editable. And our only goal is to graph this using the intercepts. See? Graph this function using intercepts. So if I want to say what's my x-intercept and what's my y-intercept, let's see what I'm going to plug in. If I'm looking for x, I make y 0. If I'm looking for y, I make x 0. I want to make sure that sinks into you, right? If I'm looking for x, I need to plug in y 0. Block off the other guy. I don't want to hear you talking. If I'm solving for y, I want to block off x. I'm talking to y here. You be quiet. You stand in the corner. Okay? So here we go. We're going to do our first example, solving for our x-intercept. 10x plus 9y equals to 90. But hey, what is 9y? What is y? We said that's going to be 0, right? So we're left with 10x equals to 90. Come on, you can do that in your head, right? X is just 9. So we know our x value is 9 when our y value is 0. That's my x-intercept. Look, we totally ran into our x value, right? That's an x-intercept because we ran into the x. However this graph will look. Looks something like that. We ran into our x at 9. It's almost like, where did the meteor crash? The meteor crashed at 9. That's my x-intercept. What's my y-intercept? So 10 times 0 plus 9y is equal to 90. If that goes to 0, 9y is equal to 90. Hey, what do you think y is going to be? Right? Y is going to be 10. 10's up here. And when you draw the two lines, ix will automatically graph these 2 points for us. Now, here is my fast way of solving this now. Okay? So here's my fast way of solving it now. I want you guys to try this. The idea of doing intercepts is that we're blocking off the other guy, right? Because he's going to be 0 anyways. Do you guys all have a thumb? Most of you guys have a thumb, right? Okay. If you guys can see me on the screen, when you guys look for your x-intercept, if you guys are looking for your x-intercept, I want you guys to actually, on your paper, you guys probably can see this, kind of ish. You just put your finger, see my finger? And you're just going to put it on, cover up the y. If I'm solving for my x-intercept, take your finger and just cover up the y, and you'll see 10x equals to 90. If I put my finger on 9y, it covers it up. And you can, what is x going to be now? Automatically, what would you say x is? X is going to be 9. You don't even have to write anything. You can just do this in your head. If I, looking at IXL, okay, just without writing any work here, if I want to solve for my y-intercept, take your thumb, take your pencil, and just cover up 10x, because if you're solving for y, block the x. Folks, what's the y going to be? That's going to be 10. My point is that we can find the intercepts really quickly, right? And that's why graphing in standard form is one of the fastest ways for us to graph. It's about plugging in 0 and solving for the value that we're looking for. Right? So these can be really fast. Let me go ahead and show you guys another example here. This one's ridiculous, right? If I block off the x, if I take my pencil and I cover up the x, what's y going to be automatically? Y is equal to 4, right? That's my y-intercept. If I block off the y, what's y equal to? X is now 4. That's your answer. Graphing using intercepts is one of our fastest ways, but this only works if it's in what we call standard form. Both x and y are on the same side. Let's jump to a harder one. Okay, this one looks a little harder, a little bit. But if I do the same trick, if I'm solving for my x-intercept, do I block off the x or y? If I'm solving for my x-intercept, answer in your brain, maybe out loud if you're alone. If I'm solving for x, if I'm solving for the x-intercept, I block off the y. So if I block it off there, 8 times what is 32? 4. Then add a 0, 40. X is 40. What about if I'm solving for my y-intercept? If I'm solving for my y-intercept, we block off the x. So what is, oops, that's a negative 40. Sorry guys, I didn't see the negative sign. Whoops. I take out that point. Okay. What is negative 32 times what is negative 320? That's going to be negative 10, right? So my y value is negative 10. Okay. So negative, oh sorry, positive 10. I'm sorry, what am I talking about? Positive 10. Okay. So it's probably best if I wrote this down, right? So y is positive 10 and x is negative 40. All right, awesome, awesomer. Okay. All right, so we have one more thing to talk about today, and that is these special graphs. Let's go back to my notes. And our next thing, besides graphing in standard form, is graphing special graphs called horizontal and vertical lines. Horizontal and vertical lines. Okay, horizontal lines and vertical lines. Now, these graphs look, so we have our x and y chart. Okay, called x and y, x and y. And kids are oftentimes confused about which way they should draw it or what are they seeing. Are they seeing the x as a horizontal or vertical, horizontal or vertical? And I want to try to clarify this for you right now. Now, horizontal and vertical lines are these graphs of functions that look like this. If I say y is equal to 3, no x and y is just one variable. Y is equal to 3. So if I give you guys a table, x and y is equal to 3, y is equal to 3, y is equal to 3. When x is 0, y is 3. When x is 1, y is still 3. When x is 100, guess what y is? Y is still 3. Y is like your stubborn grandparent who refuses to listen. Okay? So y is 1, 2, 3. That's y. And it doesn't matter. This is a horizontal line. And this is where kids get confused. They get confused because isn't y a vertical value? You're right. Y is a vertical value. But it doesn't go in a vertical direction, meaning it's not, if I say y is, look, if I say y is 1, 2, 3, see y is changing. But is y equal to 3 changing? It's what we call a constant. No, y is not changing. So the example of this is, hey, what floor do you live on? I live on the 3rd floor. So on the 3rd floor, you can walk back and forth as much as you want because you live on the 3rd floor. Do you live on the 2nd floor? Do you live on the 1st floor? Nope, you live on the 3rd floor. When I see y is 3, I'm thinking I'm stuck on the 3rd floor. That's why this is a horizontal line on 3. Vertical lines, though, are not y's, they're actually x's. X equals to, that's a positive 3. X is 1, x is 2, x is 3. You guys all see x here is 3? So if the graph is x is 3, that means it's always going to be 3. It is a vertical line at 3. Maybe I should change the color, eh? Let's highlight it. Horizontal line. And that's really the biggest difference between the two. One is an x value, one is a y value. You can understand why people get this confused all the time. Right? Okay, I see x is 3. Well, x is 3. Hello, x is 3. That goes this way, right? Because we got to hit 3. But then you also hit 2, you also hit 1, you also hit 0. That's not x is 3. That's x is changing. I don't want x to change. But what I don't care about is the y values. Look, have you ever said, you know what? I just want pizza. What toppings do you want? I don't care. I just want pizza. You can put whatever toppings you want. Right? And that's the idea here. I just want pizza. You can give me whatever toppings you want. I don't care. I just want pizza. Let's do this one more time. If I ask you a graph y is equal to 7, is this a vertical or horizontal graph? I want you guys to think about this. Okay. Y is 7. Would that be a vertical graph or horizontal? And vertical graphs look like it's going up and down, right? Horizontal graphs look like they're going left to right. One thing is to remember this. If you fall vertically, you are falling, right? Vertically. Horizontal, think about the horizon. Okay. So we've seen these words before. They play in English. There's no difference in English as they are in math. Vertical is up and down. Horizontal means left and right. The horizon. Okay. So hopefully you check that if y is 7, 1, 2, 3, 4, 5, 6, 7, we are stuck on the 7th floor here. That this is a horizontal graph. Okay. If we say x is -2, let's graph this out. X is -2, -1, -2. This is a vertical graph. I don't care what your y is. I just care that you told me x is -2. Don't care about this. I shouldn't have drawn the arrow there. That's kind of a little confusing. I do care about this. Are you guys in a family where like you're the most loved child ever? All right, you're -2 and everyone else is just I just care it's -2. And that turns out to be a vertical graph. Okay, hopefully this is helpful to you guys. If you have any questions, you guys can always feel free to email me or ask me or stay after in class, okay?